Hello everyone. Today we're going to learn about special products. So we're looking at two different types of circumstances here in this problem. You could try this do now if you wanted to pause the video here and go over that. These are basically what we're learning today. One of the special types of products are when we have something like a quantity squared. So today we're going to learn how to multiply special binomials. So in this case, we did binomials already. This is actually just going to be what we learned last time, but just more consistent. So every time, instead of being x plus 4 times x plus 2, it'll be x plus 4 times x plus 4. So in this case, x plus 4 times x plus 4 is x squared. This box will be 4x, 4x, and 4 times 4 is 16. So the answer is x squared plus, these add to 8x, plus 16. Okay, let's try this one now here. This one would be x plus 2, x plus 2, x squared, 2x, 2x, and 2 times 2 is 4. So we get x squared plus 4x plus 4. And then finally this one here, x minus 3, x minus 3, x squared minus 3x minus 3x plus 9. This ends up being x squared minus 6x, because negative 3 and negative 3, plus 9. And that is pretty much what we're going to be doing today. So it says here, draw a picture of x plus 4 squared. We actually already did that up here. X plus 4 times x plus 4 is x plus 4 squared. That's what we got right here. And a picture of a plus b squared is going to be like this. A plus b and a plus b. Notice that this actually would be a square, because if I drew a segment x, we'll say that this is x here, and then we'll say 1, 2, 3, 1, 2, 3, 4, something like that. If I multiply x plus 4 times x plus 4, 1, 2, 3, 4. If I actually draw what that looks like, it makes a square. So something like this. Okay. Kind of see what I'm looking at here. So this is the length x squared. X times x makes an actual square of x. These bars right here are 1, 2, 3, 4. These are bars of x. And these are also actually bars of length x, because it's x times 1. So that just makes this a length of x. So if you see here, we have 1, 2, 3, 4, 5, 6, 7, 8 x's. So we've got 1x squared, that's this square right here. 1, 2, 3, 4, 5, 6, 7, 8 x's. And then how many squares are we going to have down here? Well, if I drew my picture right, I have 1, 2, 3, 4 times 1, 2, 3, 4, 16 of these squares in here. There are 16 little squares in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I got 8 x squared plus 8x plus 16. This is just a picture of this answer right here. If I do a plus b squared, I've got a square of a, I've got a square of b, b times b, and then this one here is a times b. So we're going to notice a pattern here. We're going to have a squared plus 2ab's plus b squared. And that's the pattern for every single one of these problems here. So if I look at the do now problems, it was x squared plus, well, b squared would be the 4. 4 squared is 16. So I've got x squared plus 4 squared. And then do I have 2ab's here? Well, an a is an x and a b is a 4. 4x, I've got 2ab's here. Let's look at the one over here to show the same thing. The first term is squared, so x squared. The last term is squared, that's the b squared here. Minus 3 squared is negative 3 times negative 3 is 9. And then do I have 2ab's? AB is negative 3x, negative 3x, negative 3x, negative 6x. So that's our theory. I know it's a little bit complicated, but you'll get the hang of it once we do some problems. How do I make this go down? All right. So let's do this first one here. Remember our pattern is a plus b squared is a squared plus 2ab plus b squared. That's our formula for today. So in this problem, I have to square the first term and the last term. So a is 3x, b is 5. So a squared would be 3x squared, which is 9x squared. B squared is just 5 squared, which is 25. Now I have to do the 2ab in the middle. So a times b is going to be 15x. So it's 2 times 3x times 5. That's 2ab, which this would be 2 times 3 is 6, and 6 times 5 is 30. So I have 30x here. Okay, so my final answer is 9x squared plus 30x plus 25. Okay, these problems are a little bit more complicated looking, but if you just follow that procedure every time, you'll be just fine. So let's take another stab at one of these. If you want to try here, you could pause it and try it on your own. If not, you can follow me along for one more. Why is this being so jumpy? All right, so let's try this one more time. This is A. This is B. So A squared plus, I'll try to color code it a little bit better, 2AB plus B squared. Okay, so A squared is going to be 8 times 8 is 64. And that's a C there, so it's C squared. Plus 2AB. I'll write this step out. 2. A is 8C. B is 3D. Plus B squared. The B term is 3D, so it's 3D all squared. So my final answer is going to be 64, c squared. 2 times 8 is 16. And then 8 times 3 is going to be, where's my calculator? Well, let's do it this way. 8 times 3 is 24. 24 times 2 is 48. And then 3 squared is 9 times d squared. Okay, at this point, if you didn't pause it already, you should pause this, see if you can follow along with my steps here, and see if you can do number 1b. Okay, on 1b, this should have been our a, this should have been our b. We should have had a squared plus 2ab plus b squared. B squared in this case is 4y. So a squared plus 2ab plus b squared, we get 9x squared plus 12 times 2 is 24. I've got x and y in this term. And then finally 16 squared. 16y squared. That's our answer. All right, so that's it for those problems. Now we're going to look at a square of a difference. The square of the difference is honestly the exact same thing as long as you follow the rules of multiplying negatives. If you get confused with negatives, it's just type it in your calculator if that's what you want to do. So we're going to do the same thing as before. We have a minus b squared. In this case, though, I can draw a picture. A minus b, a minus b. I've got a times a is a squared. This term here has a negative, so negative b times a is negative ab. Again, I have minus b times a, negative ab. And then negative b times negative b is...
I didn't understand that.
Negative b times negative b is positive b squared. So our formula on this one is a minus b squared is a squared minus, I have two ab's here, they're both negative, so minus 2ab, and that's a positive b squared, so we write plus b squared. So let's go to this problem here. I've got a, I've got b. We do this problem the exact same way. That's almost the exact same formula, but when there's a negative sign here, the first term is negative. The second term is still positive because I'm squaring that negative b. So let's try it here. I've got a, I've got b. So I'm looking at a squared minus 2ab plus b squared. A is 2x, so 2x squared minus 2 times a, which in this case is 2x, times b, which is negative, or sorry, we're going to say 5y. And then my last term, b squared, is 5y squared. So in this final answer, I get 4x squared, because 2 squared is 4, minus 2 times 2 is 4, times 5 is 20. So I get negative 20 xy. And then 5 times 5 is 25. The y also gets squared. That is my final answer. If you want, at this time you can pause it. I was realizing while I was doing that problem, it might be easier to use your old formula and treat this like a negative 5. If you don't want to treat that as a negative 5, if you want to just say it's 5y, then use this formula. But it's up to you. So I'll do this one where I just say I'm going to use my old formula. So the old formula was a squared plus 2ab plus b squared. So I'm going to say that this is A, and in order to make this work, I'm going to say that this is B. The negative one is B. I'm going to use this formula. So I've got 6p squared plus 2ab. And see, this negative will turn that positive into a minus sign. So I'm going to get the same results as doing this formula. Okay, then plus b squared. B squared is -1 squared. So I get 6p, 36p, because 6 times 6 is 36. 36p squared plus, that'll actually be minus, because negative times a positive is a negative, so this will be minus 12p. And then this will be 1 squared is going to be +1. That's our answer. All right, at this point, you should try pausing the video and see if you can do 2b. Okay, this one might have been a little bit confusing because for the A is A, but B is 2b. It's a little bit confusing because they chose the same letters as we have in our formula, but the way you do it is just the same. A squared minus 2ab, in this case, it's 2b, and then plus 2b squared. We should have got something like a squared, -2 times 2 is minus 4ab, and then plus 2 squared is 4, 4b squared. That's our answer. Okay, I know I'm done, by the way, because this term has an a, this term has an ab, and this has a b. Or well, actually, an a squared and a b squared. Since none of them are like terms, I'm done. I don't have to keep going. If this had an a and this had an a, I might have to keep going. All right. We're going to look at a couple word problems here, and we're almost done. So in this problem here, it says physical science, each side of the edge of a cube is 4 centimeters less than the edge of a copper cube. So my guess right here is that this one right here, this is my copper cube, because they picked C. C for copper. And the aluminum is 4 less, so they did -4. Aluminum. Write the equation to model the surface area of the aluminum cube. Okay, well this one's going to be a little bit tricky because you have to know the formula for a surface area. So surface area of a cube is the area of each side, and then we're going to multiply it by 6. So the area of the side of a cube is, we'll say, s squared. This is one side because it's side times side. But there's 6 sides on a cube, so I'm going to multiply this by 6. They're all the same side. If you think about like a dice or something like that, each side is the same size. So the surface area is this outside, it's 6 times s squared. So we want to know the area of the aluminum cube, this one here. Fortunately, they drew a picture for us. So it's C minus 4, that's our side. And I have to square it because this side times this side, which is also C minus 4. So let's square it. And then there's 6 sides, so I'm going to multiply that by 6. I'm going to say surface area is 6 times C minus 4 squared. Well, this is what we were just practicing a second ago, where I have A times B. So I'm going to multiply this out. I could, like, if you wanted to, you could draw the box on this. You don't have to use the formula. We could say, all right, C minus 4 squared is the same as C minus 4 times C minus 4. And then you could draw your square, C minus 4, C minus 4, C squared, minus 4c minus 4c minus or plus 16. You can do it that way. That gives you c squared minus 8c plus 16. Or you use the formula where you just say square the first term, multiply the next two terms, and multiply it by 2. So 2 times c times negative 4. And then square the last term, which will be plus 16. If I simplify this a bit more, I get 6 times c squared plus, is that, no, that should be minus. That should be a plus there. Okay. We get c squared. Negative 4 times 2 is negative 8c plus 16, which is the same answer we got over here. And now we just multiply everything times 6. 6 times a is 6a squared times 8 is negative 48c, and times 16 is a problem I don't know how to do. 6 times 16, 96. And it just says write an equation. So it should have an equal sign here. We should say surface area equals 6a squared minus 48c plus 96. That is it for that. You should pause the video now and see if you can do the gardening problem. It is jumping a lot. Okay, after you're done with that, I'll go over this answer, so pause it now. It says, Alano has a garden that is g feet long and g feet wide. He wants to add 3 feet to the width, to the length and the width. So it's currently g by g, and he wants to add 3 feet and 3 feet. Plus 3, plus 3. So this will give me g squared plus 3g, 3g, and this will be 9 feet here. It says, show a binomial of the new area. Okay, well, we already did the problem, but the binomial of the new area is g plus 3 squared, because I'm going to add 3 onto both sides of the square. That's our binomial. Find the square of this binomial. Well, we just did that here. This is the square. G plus 3 squared is g squared plus 3g plus 3g is 6g plus 9. Almost drew a g there. And that's it. Okay. Our last example here is just finding the product of a sum or difference. These are, they're going to be pretty similar to the problems we've done today, but you'll notice a pattern here that comes out. These are actually, I like these problems because they end up being a little bit simpler in their answer. So I'm going to start by drawing a picture of this. I'm going to draw it over here where I have lots of space. I've got 2x squared plus 3 and 2x squared minus 3. So in my first box, I've got 2x squared times 2x squared. That is 4x to the 4th. Remember, when you multiply these, you add up their exponents. In this box, I have 3 times 2 is 6x squared. In this box, I've got negative 3 times 2 is negative 6x squared. And in the last box, I have minus 9. These two terms are positive and negative. They add up to 0. So my answer here is 4x to the 4th minus 9. These two terms canceled each other out. And that'll be the pattern every single time if you notice that the parentheses have exactly the same thing in them, but the sign is different. So earlier today we did, what if they're exactly the same, g plus 3 times g plus 3? We get an extra term in the middle because of these. They multiply and add together. But whenever they're opposite signs, we lose a term in the middle because they cancel out. Let's do another one here. I can already see what the pattern is. I say, okay, it's going to be 3n plus 2, 3n minus 2, 9n squared. These are going to be 6n. These are minus 6n. Okay, you notice these two are exactly the same but opposite signs. And this is minus 4. These terms cancel. I get 9n squared minus 4. At this point, pause the video, see if you can do this problem here, 4b. See if you can also do it without drawing the picture. See if you can pick up on the pattern. Okay, so the first term is 4c times 4c, which is 16c squared. The middle two terms are going to be, 28 CD and negative 28 CD, which will cancel. So I'm not even going to write that. And the last term will be minus 49 D squared. Because 7 times 7 is 49, and D times D is D squared. That is it for what we're learning today. At this point, pause the video, see if you can do the performance of understanding, which is listed below. Right here, these 5 problems here. See if you can do all 5 problems. When you're done, unpause the video. I'll go over the answers. Okay, the first one was x squared plus, remember it was 2 times AB, so that would be 10x plus 25. Here we're going to have 121 minus 22a plus a squared. I squared the first term, I squared the last term, I doubled the middle two times each other. I had a teacher who used to call this square double square, because you square, you double the middle two, and then you square. This one here would be 4x squared plus 28xy plus 14y squared. And then finally, well, not finally, we have 2 more. 3m times 3m is going to give me 9m squared. And then the double is going to be minus 3 times 4 is 12. So this will be minus 24m. And then square is going to be negative 4 times negative 4 is 16. Okay, this one looks a little bit tricky, but it's not that bad. It says find the total area of the figure to the right. Area is, if it's a square, side times side. So I've got 2 squares in this picture. Square 1, we'll do the little guy. X minus 1 times x minus 1. Square 2 is x plus 2 times x plus 2. And then they're just right next to each other, so I'm just going to add them up when I'm done. The first term will be, or the first square is going to be x squared minus 2x plus 1. And then I'm going to add that to the second square, which is x squared plus 4x plus 4. We did this problem already in the do now. Now I have to combine some like terms. I do have some like terms in this problem. So I've got 2x squareds. I've got a minus 2x and a plus 4x, which will add up to plus 2x, and a plus 1 and a plus 4, which is plus 5. So that's my answer on this problem here. Okay, if you are looking for something to do, here are some good practice problems below. You do all these practice problems. Ooh, what am I doing here? If you want something to do, these are some good practice problems. None of them are too crazy hard. There's lots of practice problems. you should be able to follow the patterning and do it pretty simply. All right, if you have any questions, you can post them in the comments. I'll try to keep an eye on those. And feel free to like or dislike the video. All right, have a good day.